All right, so angle bisector. Obviously, we're going to bisect angles, right? Okay, so let's fill in a few blanks they've got down there. Angle bisector, line or segment from the vertex to the opposite side such that it bisects the angle. Okay, one endpoint is always a vertex. The other one, we don't know what it is. It doesn't matter. Okay, so like when we're doing an angle bisector, if I bisect this angle here, we don't know where it's going to go on this side. It doesn't matter. It's as long as it bisects the angle. Does that make sense, everybody? Okay, the point of concurrency, we're reviewing that again, is where three lines meet, right? Okay, the angle bisector's point of concurrency is the incenter. Okay, so that means here's what's special about it. So first off, everybody get incenter down. All right, now circle it or however you want to do it. But that point where all three cross, that point of concurrency is the incenter. Now here's what's special about it. Now I'm kind of like shortening it into layman's terms. Equidistance is probably what they're going to use. But if you just remember this, it's equal from each side. So the incenter, when I draw in all three angle bisectors, that point where it meets, going straight to that side, going straight to that side, going straight to that side, are all the same. Does that make sense? Okay, now here's why I wanted you to get your compass. So on that triangle, what I'd like for you to do you guys see the right angle marks they put there? Now what that is telling you is, so from this point straight to that side, that's the distance, right? Shortest distance. Okay, so I want you to put your point right here. Does that make sense? Put your pencil right there and make a circle and look what happens. Okay, so if you got one, do that. If you're by somebody and you need to borrow it, I think it'll help you if you see it. It's not going to like change the world if you don't do it. But when you draw that circle in there, what do you notice is happening? There's a circle that is where based from the triangle. How would you describe where that circle is? In the middle? Inside? Would everybody agree it's inside? Looks like it's in the middle. Here's what it actually is. It is, okay? So I want you to write that word, inscribed. So basically what that means is that's the biggest circle that will go inside that triangle. Does that make sense, everybody? It's going to barely touch the triangle at three places. So if you were trying to figure out what's the biggest circle I could put inside a triangle, I would draw in what segments? Everybody listen to what I just said, okay? Because I know you guys were doing stuff. So if they said, hey, you got this triangle, some random quiz test problem. I want you to draw the biggest circle you can inside the triangle. What segments would you need to draw in? Well, we need to find the incenter, which means we would need to draw what? Angle bisectors. Does that make sense, everybody? So if you had a problem where I wanted to figure out and draw the biggest circle in a triangle, I would draw in the angle bisectors because they would meet at the incenter. And the incenter is the center of that circle that is inscribed. Does that make sense, everybody? Now, the good news is that's all you have to know about an angle bisector, okay? So let's turn the page, and I'll show you how they will give you some problems. All right, so on 3A, what are they saying is true about BP, AP, and CP? They're angle bisectors. Now, on your picture, they didn't draw the angle bisectors all the way across, did they? Okay, because remember, really, the only thing that matters for an angle bisector is it bisects an angle, right? Doesn't matter where it goes to, does it? Okay, so my question to you is, this point where all three of those are meeting, what's it called? It's the incenter. So I want you guys to write that down below it there. P is the incenter, just to emphasize that. So where the angle bisectors meet is the incenter. And what do we know is true about the incenter? It's an inscribed circle, right? Which means it's equal distance from each side. Now I'm kind of changing up this problem. So we're going to answer it first, and then I'm going to ask you another question. So PX is right here, isn't it? PY is right here. And then PZ is right there. You guys agree those three would have to be equal to each other, correct? So if we drew in the circle, what would those be for the circle? What could you call it? What part of the circle goes from the center out on the circle? The radius. Like if we drew in our instant, right now, if you took your compass, if you want to, go ahead and do it. I think it helps. Just go ahead, put your point there, put your pencil on Y, make a circle. XP, PY, and PZ are all the radius of a circle. Those are the three radiuses of your, there are three radiuses of your inscribed circle. If I get that out of there. Whew. Okay, is everybody good with that? And then just real quick, if you look at 3B, we know that PY and PZ are equal, right? Correct? So if they give us expressions for both of them, 2x minus 7 and x plus 4, we just solve for x, don't we? And you would get x is 11 when you worked it out. So recap real quick. What do we draw in? So I'm doing this a little bit different. What do we draw in to find the incenter? Angle bisectors. Why do we draw in the angle bisectors? Because they will cross where? At the incenter. The incenter is the center of that inscribed circle, which means it is equal distance from each side. So there'll be three things that are equal to each other, won't there? Because there's three parts that touch. 1, 2, 3. And if I drew the circle in, it would go right there. Okay? Is everybody good on that? All right, so I'm going to give you like 10 or 15 minutes to work on practice. And then when I stop you, we'll do the quiz. We'll take a break. And then we will come back and do that second part of the lesson. Okie doke? Let me turn this off real quick.